Geometry 7-3, Example 3. Are triangle PQS and triangle RQP similar? So take note of our different triangles here. The first triangle, PQS, is this big triangle right here. So let's redraw it separately so we can look at it a little bit easier. So that's PQS. And let's go ahead and write the measurements on. PQ is 18, and 15 plus 12 is 27. The second triangle, RQP, is this triangle right here. RQP. We know that this piece, PQ, is still 18, and we know that this piece is 12. Because Q is the same angle for both pieces, we would use the reflexive property to say that angle Q is congruent to angle Q. Now we just have to check to see if the triangles are similar. Which pieces are we going to compare? We see that PQ, according to this triangle, should match up with RQ. So those should correspond. So let's put PQ, which is 18, over RQ, PQ over RQ, which is 12. And then let's put QS and QP together. So QS is 27 and QP is 18. So if we punch that into our calculator, we can do 18 divided by 12, and we get 1.5, or we get 27 divided by 18, which is 1.5. Another way to check the proportionality is to look at the proportion of 18 over 12 equal to 27 over 18, and we can check the cross products. So we can do 12 times 27, which is 324, and then we can do 18 times 18, which is 324, so that is proportional. So because it's proportional and we have the angle in the middle of those two sets of sides, we can say that triangle PQS is similar to triangle RQP by the side angle side similarity theorem. If you're feeling ready for a challenge, go ahead and pause your video and try it on your own. If you're still feeling a little frustrated, perhaps go ahead and stay as I explain it. In part A, we're looking at triangle ADE. That's this triangle out here on the edge. And we're comparing it with triangle ABD. ABD. So we have these two triangles that we're comparing. Notice that we're given all of the sides. So we need to look at how we're going to match them up. AD will match up with AB. So AD is 2.4 and AB is 3.2. Then we're going to match up DE and BD. So DE is 1.8 and BD is 2.4. And then we'll compare the third side, which will be AE and AD. So AE is 1.8 and AD is 2.4. So taking note that these two pieces are the same, I'm going to go ahead and just look at this first part, and I'm going to compare these proportions. Remember, you could do division on both sides to see if you get the same fraction, or you can multiply and find your cross products. So I'm going to do 3.2 times 1.8. That gives me 5.76. And if I do 2.4 times 2.4, I get 5.76. So they are proportional. And so triangle ADE is similar to triangle ABD by side-side-side similarity theorem. If you did the division and did 2.4 divided by 3.2, you would have gotten 0.75 for each of those proportions. On part B, we're asking if ADE is similar to BDC. And ADE, again, is this triangle out here. And then BDC is this triangle over here. So we're comparing those two triangles. Notice that we have the angle in here and the angle here. So we have an included angle, and now we need to look at the corresponding sides. So if I have AD, which is 2.4, going to BD, which is also 2.4, then I'm going to compare the other sides on the other side of the angle, ED and DC. So DE is 1.8 and DC is 1.4. We can tell right away that this is not equal on either side. So the triangles are not similar.